In this video, I'll show you how to assemble your snowblower kit. You can either buy the kit from me online, or you can buy the files from me and print your own, and you can buy the hardware if you print your own, or if you buy the kit on my website, all the hardware is included with it. Actually, I shouldn't say all the hardware. Besides that hardware kit, you will also need a Traxxas slipper clutch, and a Traxxas Emax or Tmax differential, and you can also buy these from me on my website. And when you order a kit, if you don't order a mount kit for the Blizzard, it will come with these blank brackets on the back side of the snowblower where it actually connects to the machine. These ones are included if you don't order a mount, because it's up to you to connect this to your, like, whatever vehicle you're trying to use the snowblower with. But if you order a front or rear mount for the Blizzard, then your kit will come with these instead. These are designed to work with the Kyosho Blizzard. Some of the items in your kit may vary from what you see in this video, but the overall assembly will remain pretty much the same. You can start unpacking your hardware kit, and remember that you also need a Traxxas Emax or Tmax differential and the Traxxas slipper clutch. I normally use 3 little bins. Just helps to organize all the screws. So we got threaded rods for the auger, a timing belt for the main drive, a bunch of different bearings, and the aluminum scraper bars, and a whole bunch of screws. If you order the front or rear mount for this Kyosho Blizzard, your kit will come with a control rod set that works with the Blizzard stock plow. But if you don't order those kits, your snowblower kit won't come with that. We got the motor screws for a metric 550 or 540 motor, and then special screws for the aluminum bar, really thin lock nuts. I normally put that and the miscellaneous screws in the same bucket. We got number 4 screws, mostly 440, and some number 4 sheet metal screws. And then number 6 screws. So the first thing we have to do to get ready to start building the snowblower is to convert the Traxxas differential into a solid axle. As you see, it spins backwards, which on the snowblower we don't want that to happen. You see, on this one's locked, so when one auger's going through snow, they both spin like equally. So to do this, we need some JB weld to lock the gears on the inside, safety glasses, and a cutter that you don't really care about because we're going to be cutting off this lip right here. And there's 2 different differentials. One of them uses an Allen wrench, but this one that I have here is the Phillips one. So first thing I'm going to do is take that ring off and open the thing up. So once you have everything taken apart, you can start by cleaning some of the grease off of everything, because it's easier to work with. And then next thing you gotta do is open the diff gears up. So once you get that open, make sure to keep the gears together. Like, this gear is different than this one on this side. I think it's a slightly different length. So you want to take all the parts out. And clean as much of the grease as you can off, but you don't have to be perfect. So once you're done with that, then you'll want to get ready to start mixing up the JB weld. They sell a lot smaller one than this, but I have the large size. I would recommend getting a hold of this because it's like a cold metal weld. It's a lot better than like an epoxy or glue or anything. But it's equal parts that you mix up. So once you have it nice and mixed up, then you'll want to put the gear that used to be down here back in here. And then you'll put some of the JB weld in there. It'll kind of flow on its own down at the bottom. And here you don't want to put too much because you can overfill it. And then we'll take the two smaller gears, put them on that shaft. And if you look closely, one of the sides is square. That's where the shaft goes in. And then use the other gear just to push it down. And then put just a little bit more JB weld in here. And then you'll want to turn it just so it kind of all gets mixed in. And then take a towel and just wipe any excess on the top off, because you don't want it making its way into the gears on the outside. Then line the gear back up with the holes. And then you'll screw it in. So once you have this screwed back together, you're going to want to look at the outputs here, and you're going to want to line them up so the flat spot is the same on each end. The drying time for the JB weld is, I think, like an hour or two, so you have plenty of time to line them up. And then the next step is to take the case, and this lip on each one we need to remove for the augers to fit on. So what I do is take an old clipper that you don't care, because this plastic's kind of hard, put some safety glasses on. I normally do this above a trash can, but this works here. I go in and I start clipping that off. You can use a Dremel if you want, but I find that this is easier. Just that first lip is what you want to clip off. Then once you have most of it, we'll take a piece of sandpaper and just sand it off the rest of it. And then do the same thing to the other side. So once you have both of those cut and sanded, then you're going to want to reassemble the whole diff. And you'll probably want to put some more grease in there. I just use some CV joint grease because it's anti-seize. And the Traxxas diff comes with this stock ring, but in your kit there's a 3D printed ring because those posts get in the way of the augers. Before you screw it together, you're going to want to take the support piece from your kit and two number 4 washers. Put 2 of the washers over the screws here. And you'll see one side of this has like a bevel in it. You want to put them through the flat side. And on this, there's a thick side and a thin side. You want to put this through the thin side like this. Then once you have it screwed in, just check one more time to make sure that the 2 flat spots are like in parallel with each other. And then you'll want to set this aside for at least a couple hours to harden, and then at least make sure you wait overnight before actually using your snowblower, just to make sure the JB weld cures in there. To start assembling the snowblower, this is the stuff that will be needed. A standard Phillips screwdriver, an X-Acto knife, and a file to help clean up some of the parts, needle nose and normal pliers, a 1/4 inch and 7/16 inch wrench, some grease, super glue and thread lock, and a hammer and a vise, but those are not completely required, they just help. We use the vise to press the bearings into some of the plastic parts. You'll need the main case, the post, and the chute mount for this. 2 number 4 by 1/2 inch pan head sheet metal screws, and a flat head number 4 sheet metal screw. We'll take a little bit of super glue on the bottom there, and it's going to be going on the back of that. We'll put the screw in through the front. The reason we have to super glue this is when you tighten the belt cover on, you don't want this post spinning on you. And then after that, we'll put on the chute mount. There's a ring or a lip that this thing slides in, and then you put the 2 screws on the back here. Now when you're tightening these type of sheet metal screws into plastic, they create their own threads as you screw it in. And these you'll feel when they bottom out. Like right when you feel it start to stop, then it's tight. Just like that. Next we're going to put on the bearing for the drive shaft. First we gotta press the bearing into the plastic piece. This is where a vise is very useful. If you don't have a vise, you could just use like 2 pliers on each side. I would not recommend using a hammer because you would probably damage the bearing. And what you want to do is take the number 4 or 440 by 3/4 inch screw with 2 washers. Put them in inside the case like that, and then you can put 2 fingers on them to try to hold them from falling out. And then on the other side, you want the whole bearing to face down on top of that. And then put 2 more washers and the lock nuts. And then tighten them down. You don't have to go too crazy when you tighten stuff like this. Just enough pressure is good enough. Next, take the large cover plates and whichever bracket set you're using. Like I said at the beginning of the video, there's two different kinds for custom vehicles or the Blizzard. And take 8 number 6 by 1/2 inch sheet metal screws and 8 number 6 washers. And what we're going to do is screw this piece on here. It's a little difficult to do because we have to flex this piece when we screw it on. But you line it up with those 4 holes there. And you put the screws, you start them on the flat side. Don't start them on the side that has the grooves. This is the back side, and this is the inside of the snowblower. We'll start one screw right here. Don't tighten it all the way yet until you get all 4 of them in there. Oh, also, the shape of this, the thicker part, goes towards this triangular part here. And if you look at it from the back, it goes towards the hole. If you were using the blank mount, the thick end goes on the bottom like that. And then you can just kind of slowly tighten them down as you try to make sure it's nice and flat on that curved part. Like I said, it's a little difficult to do. Once you got it, the gap should be pretty nice on there. And then we'll do the other side. So there we go. So if you put the hole together like that, that's how those are supposed to go on. The round part towards the bottom, and they're on the back side where these bumps stick up. Next we're going to take 6 number 6 sized by 1/2 inch sheet metal screws and 6 number 6 washers, and take all the stuff we've been working on. And best way to start is put one washer through that center hole there and start screwing it into here. And then we'll take another screw for here. And one more up here. These sheet metal screws, they work a lot better than using like fine pitch, like metric thread into plastic, like a lot of RC companies do. If you look up close, they have really like hard pitched teeth on them. So I know a lot of people were worried about me using this kind of hardware. They were worried about it stripping out. But with these screws, it only really strips out if you go overboard and tighten it too much. Like right when you feel it stop spinning, just go just a hair more, and then it's tight enough. On screws that have the really fine pitch thread going directly into plastic, it's really hard to tell when it's actually tight. That's how a lot of people strip that stuff out. But I found the sheet metal screws, it's so much easier to tell like exactly when it's tight. So people should have at least less of a chance of stripping than with the fine pitch stuff. So once you have all 6 screwed in, it's starting to take shape of a snowblower. Don't worry about how it's all bent like this. Once we get the other parts on, it'll straighten out. Next, we're going to take all these pieces here, this bar with 4 holes in it, the 2 colored pieces, and the deflector piece that kind of helps block snow from getting thrown out the front. And then we need 2 440 by 1/2 inch screws with 4 washers and a lock nut. And then 4 number 6 sheet metal screws by 3/4 inches long. And we'll start by putting these on the ends of this. And this goes up here. And then we'll put the washers and lock nuts underneath. And don't tighten those down yet, because then we're going to put the 3/4 inch long screws through the back here. And they'll go into the bottom of that. And this bar on the top is used to kind of connect both of these plates together, because most people's printers aren't this large, so I made them 2 separate pieces. It's about 14 inches long. Even my printer can't do this. I use 12-inch printers, so it's split up into 7-inch long parts, just in case you guys are wondering about people who print their own. And then next we'll take this part, will go like so, and then you'll run the same screws through the back of this part here. I have to slowly tighten it down so it stays even with itself, the front part I mean. So that's how it should look when it's all done there. Next we're going to put on the main aluminum slider bar that goes on the bottom. We'll need 8 3/8 inch 440 flathead screws and thin profile lock nuts for them. They come in that separate bag that says metal bar screws in the kit. And then we'll just start screwing them in. The countersunk part faces the bottom of the snowblower. And these you do not want to over tighten. Just once you start feeling it get tight is good enough. And you'll notice the nuts on top don't actually sit flush on the part, because the way this was 3D printed, you couldn't really make that angle very easily underneath for the screw to fit. There just wasn't enough material there. So they're kind of at an angle, but it still works just fine. So when you're done, it'll look like that. And this aluminum scraper bar adds like a huge amount of strength to the whole snowblower. Next, we're going to start the assembly of the drive shaft and the impeller. First thing we got to do is take the 1/4 inch 20 lock nut, and we have to get it inside here. You want the lock ring in there to be facing up, and this is another easy use of the vise here. And then I also need to take the screw and just pound it the rest of the way down there. And you can just pry it back out. So it should be that far in the hole there. Then we'll take the other half, put some super glue on it. You can also use any kind of ABS glue, because all my kits are normal ABS plastic. You can even use that clear pipe glue they have, where it's like a pipe cement, but I find super glue works good enough. Also helps if you have any accelerator. Just give it a squirt. And then we'll put the impeller on the drive shaft. The drive shaft has a hex on one end. That's the end you want to start the impeller, and you want to line up both of those holes. And then we'll take a number 632 by 1.5 inches screw. And I put the head of the screw on this side where the flat spot of the impeller is, because the other end sticks out a bit, but the impeller spins this way, so it scoops the snow up like that. Just keeps the screw out of the way. And don't go too tight on this. Just tight enough so the screw won't vibrate on you, but don't go too tight with that. So now the drive shaft is all ready. Next we take the differential. Make sure that you let it dry enough, or if not, just make sure these always stay parallel in case you bump them or something. Or if you order this from me, you don't have to worry about any of that, because it's already dry. And now we're going to put the impeller on the gearbox here. But certain Traxxas differentials, there's the old style and the new style. This one's the old style. The old style has Phillips screws. The newer style has black Allen wrench screws. The newer style is slightly shorter. So if you have a newer one, you want to put this washer on there, but you don't need this washer on the old one. So what we're going to do is just take a little bit of grease, put it on the top of the drive shaft there. Oh, also the newer diff uses the hole that's closer to the front, and this one uses the hole that's farther back. So there's two different ones. So we'll put that in there, and then we'll take the 2.5 by 25 millimeter screw and a lock nut. Now, sometimes, like if you print your own, sometimes this drive shaft might be just slightly off. Like you want it to spin freely like this. If it's really hard to spin, you might have to take it off and just file the end of the drive shaft down a little bit. Or you might even need to oversize drill the holes, because you want a nice fit. But if it's too loose, when the snowblower runs into stuff, the gears will actually grind, because the gear in here will be pushed into the bevel gear. So you want it just enough so where it spins freely but not too loose. And then we'll go ahead and tighten that down. And this you want just ever so slightly tight, just enough where it doesn't vibrate. If you tighten it a little too much, it'll actually squish the plastic enough where it actually pinches it, so it's hard to spin. So just so it's not vibrating in there. So there's the impeller assembly. Next we're going to take the main assembly and the impeller, and we're going to insert the impeller with the drive shaft end into the bearing inside here. Sometimes you might have a hard time pressing it through the bearing, especially if you print it yourself, like the tolerance might not be right on. So you need to sometimes file this round part down just enough so you can fit it through. This is how it should look coming out the back. The hex end should stick all the way out like that. And then on the front, we'll use some 440 by 3/4 inch screws with washers and lock nuts. Washer on each end. And don't tighten these all the way down, leave them a little loose. We're going to tighten them down after we get more of the blower assembled. So then, to connect this one, you have to bend the whole cover down like that. Normally the screw in there is enough to hold it from flying back up. And all these holes are oversized, so we'll leave it loose until we complete the next step. So next up is the slipper clutch assembly. What a slipper clutch does is it basically is an adjustable weak point. So if you hit ice or rocks while you're blowing snow, this clutch basically, these brake pads slide on this, so it has like some give in it. It prevents the auger and basically the whole machine from getting damaged. So to start the assembly, we'll take this wear plate here. Your kit will come with one extra one of these. This ring is what rides on this. Sometimes when the slipper clutch gets overheated, it could damage this plate. That's why I included an extra one. But we'll take this and press fit it onto the shaft there. And then we'll put the ring on top in that groove. Then we'll take the little brake pad looking things. Now this Traxxas slipper clutch, this ring and these brake pads come in one package. They offer an upgrade for their trucks that are aluminum pads, but I would not get those because those would generate a lot more heat than these would. But you want to push these pads in the groove of the main pulley. Sometimes you might need just a little dab of super glue to hold them in there, but they should press fit into most of the printed parts. Sometimes if you flip them around, the other edge catches better. And then we'll take the 1/4 inch flange bearing, and the flange goes on the back side. Then we'll take the screws here, 1/4 20 2-inch bolt with a 1/4 20 washer, and a spring that has a pretty strong spring to it. Check the parts list if you're printing your own kit. I have the exact specific springs that I use here. And then you put a washer on the end. Put the smooth end of the washer facing like that way. And then we'll put the bolt through the back of the pulley. Try to keep the pads from falling out. And then we'll want to flip the whole assembly upside down. Make sure the ring is centered still. And then with your other hand, you're going to want to hold the impeller from turning. And then with your other hand, you're going to push while you're turning. And you should engage that lock nut that we put in the drive shaft earlier. Just hand tighten it for now. And then if you look right through this gap here, just check to make sure that everything's lined up right. You can see the ring and the pads is all lined up right here. Then we're going to take our 7/16 wrench while you're still holding the impeller with your other hand. We're going to tighten it all the way until it bottoms out. And then we're going to do 3 full turns, like loosening it. There's 1. 2. And 3 full turns. That's a good starting point for the tension of the whole clutch assembly. And then you'll want to check one more time just to make sure everything's still in alignment. And when you spin it, it might feel a little tight. That's because we still haven't finished tightening these bolts down yet, which we can do that now. If you kind of wiggle it around, you'll see kind of like the sweet spot where it sits nice and level. Then we'll come in and tighten those down. And it should be pretty easy to spin by hand. If it is too tight, then you might have to file the end of your drive shaft down a little more, like it might be binding too much here, or readjust all of these 4 screws until it's where you feel it should be. But it's pretty easy to turn, but it's not free spinning. It's got some tension on it. So the next step is definitely the most time-consuming of the whole build. We're going to start assembling both of the augers. So first thing you do is all the auger parts. There's a right and a left side. You can see on the part itself there's a little 3D printed letter. So each side is mirrored, and there's 3 different shapes. There's the front end where the pin goes through, the back end that fits through the bearing, and then all the middle pieces. So what you want to do is take all the middle ones, and the groove will actually snap together. There's 5 middle ones and then 2 end ones. And then we'll take one of the threaded rod pieces and you slide it all the way through the rounded end until it's flush. And once we tighten on all the blades, there's enough like tension inside there to keep that from sliding out on its own. So that's all you need to do. We'll do the same for the right side. And the left side, it's actually if you're facing from behind the snowblower. So when you look at the front of the snowblower, the left side will actually be on the right side. And then the blades, there is a right and left side of the blade, but each auger takes 2 of each. If you look at the blade, one side of the surface is much smoother than the other side. This is what prints flat in the printer, and this is what's facing upright. So the reason I made it right and left is because the bottom side is much smoother. And then we'll use all this hardware here to start assembling the auger. There is 24 440 by 1/2 inch screws and 48 440 washers, actually 52 including these, and then 52 lock nuts, 4 440 by 3/4 inch screws, and these are number 6 oversized fender washers. These fender washers we'll use to connect the blades in the middle, because it actually uses two parts like this. Since you couldn't print that flat, you know, when you stretch it out, the center had to be connected. So it's a little complicated to start the auger, but once you get going, it gets pretty easy. Like this will be if the snowblower is facing towards us as it's spinning. Oops. You can see the shape of the blades kind of slowly goes towards the center. And that's the left side. So what you want to do is take the piece that looks like this, and you'll basically start down here, because where the pin goes, this is going towards the snowblower's center, so you'll want all the smooth ends of the blades to be facing that way. Then we'll take a screw, put it through like that with a washer and lock nut. And I do all of them just hand tight until you got them all in there. And then what you'll do is you'll take the blade and kind of curve it up to the center post like that. It's a little tricky the first couple blades, but once you get a couple done, then it'll make more sense. And then I skip a hole just so we can get it going. And then put the washer and lock nut. So it'll look like that to start with. And then the same shape will start on the side right across from it. It's the exact thing that we just did, except on the other blade, basically. And this one, once you get one screw on, then you can kind of guide the blade up to the middle like that. I like to do, I like to skip the center hole on the blades and just come back to it later, just because it's easier to get all the ends screwed in. And then just make sure that the smooth part is facing towards the pin here. If this was the rough side, you'd have to use the other side of the blade. And then when we go to the next half, we use the reversed side of the blade. And this will start on the top here. And then it's pretty much the opposite of what we've been doing, just the other direction. Once you got one screwed in, you just kind of bend it to fit, and this one will touch that one now. And then we'll put another screw here. And then we'll do one more. And same thing, once you get one, just kind of slowly bend it down into place, touching the other side in the center there. And we'll put another screw in there. So now we have the basic shape of the auger is assembled. You can see when I spin it, the spiral goes that way, because this will be the center. And now, to connect the center of the blades, we'll use the longer screws here. Actually, that's right, it uses the oversized washer on the top there. And you can see there's half a hole already made, so you kind of line it up in between those holes into the blade there. And then on the other side you take a washer and a nut. And the reason I had such a long screw for this is it's just too difficult to do all this with a shorter screw. Like, it takes too much pressure to actually pinch those blades tight. So it looks a little different than the other blades, but it was necessary, basically. And then we'll come in and tighten them down. And as you tighten it, you'll see a gap. You can just kind of push the blades back into place. That little notch in the middle will keep them mostly centered. But every couple turns they'll open up again, and you just push them back together. Kind of helps if you push it on the table while you're screwing it in. And once you have it tight, it's a nice, strong connection in the middle there. And then we'll do the same thing to this side, and then tighten down all the screws and put the screws in the holes that we skipped. So I have finished screwing down the rest of the screws on the left auger. This is what it should look like when it's all done. All the smooth ends of the blades face towards the center, so when it's, you know, actually pushing snow in, the snow can slide across there. So I'll start the right one. I'll show you just the first couple blades. Start with this one. Goes on the bottom here. Smooth end facing the pin. Take the blade and slowly curve it up all the way to the center. And then we'll take the opposite blade, start it right here. And then take the curve, slowly curve it into the center. And then you do the same exact thing I just did, but on the other side to complete the spiral. And then you do what I showed you before, where you use the number 6 fender washer going in through there with the nut on the other side to clamp it down. So now that we have both augers done, I'll just show you what the end result looks like. Here's the right one spinning. See all the smooth ends towards the middle. So when they're both spinning, it kind of goes in towards the center like that. And then you'll be left over with 4 spare blades in case any of them get damaged or broken or something. We're now ready to install the augers in the whole snowblower. So what we do is we take the 2.5 by 25 millimeter screws and lock nuts and take the side that looks like that, put it on the Traxxas diff like that. Make sure, let's see, yeah, make sure the hole's facing up. We'll drop a pin in. And then on the other side, I'll have to put the lock nut. Kind of helps if you turn the whole thing upside down. Just enough so the lock nut engages. And we'll do the same to the right. So now we have the augers installed. Next we're going to start the skid shoes and the side plates here. So first thing, we'll take the smaller bearings here, press them in like so. They don't go all the way in. They stick out pretty much that far. Okay, now we have those pressed in. We'll start assembling the skid shoe. It's basically just a bent piece of metal that goes on the bottom of this here. We use the 3/8 inch flatheads and lock nuts. Okay, once you have those screwed on, then we'll take one of these, flip it around, and they go on the outside like that. So we'll take some 440 1/2-inch machine screws, with a washer and nut on the inside here. As you see, you have like this much room basically to adjust the height that the snowblower rides on the ground. And right there is where I find a good starting point. Just right so the whole aluminum part sticks above the surface. It's like a good starting point. And then I'll tighten it all the way down. Next, we're going to be attaching the side plates to the whole snowblower. To start with, basically put the bearing in the end of the auger here. Flip the machine over. The bottom hole takes a different screw than all the rest. It's a number 6, I think it's 5/8 inch flathead. And then on the top also uses a different screw, 5/8 inch number 6 screw. And then there's 4 more holes down the side. Those all use 1/2 inch number 6 sheet metal screws. So, and then we do the same exact thing this side. Just remember the flat head goes on the bottom, the longer 5/8 inch screw goes on the top, and the 1/2 inch ones go down the side like that. Once you have both sides screwed on, it should look like this now. It's pretty much a snowblower at this point. Next thing we're going to do is assemble the chute. This is really simple. Just 2 440 1/2 inch screws. Go right in the ends here with a washer and lock nut on the inside. And that's all there is to that. Then to install the chute on the snowblower, it actually is a snap fit on here. It takes a bit of force to get it on, but once it's on, it's very easy to turn. And that joint has strength enough to lift the whole blower up. The chute comes with an accessory now. It's basically like a snow blocker for really powdered snow. The way it works is this like notch goes down in the chute like that, and you push down on it to curve it, and then you use the tabs there and snap it onto the chute like that. I made it removable, so if you're doing really wet snow, I know the full-size snowblowers, they had, or some of them have an option to take it on and off, but it basically just press fits on the wall, and it has enough strength to not let snow fly it off, then easily removable. So the next thing to do is install a motor. The kits that I ship out with the electronics kit just come with a standard 27 turn brush motor, and includes a Hobby King 45 amp brush speed controller. But I take the thing apart and basically change all the wiring on it. I add a really long wire for the motor to come all the way outside whatever machine you're running it through, and I change the Tamiya connectors out to Dean's. And it comes with a plug you can solder on for whatever battery setup you're using. I would recommend doing the same thing to any speed controller you're using. I know keeping it short wires is best, but this thing isn't all that power hungry, especially with the slipper clutch in there. The machine's basically saved from any really hard loads with this. And I've found that a 27 turn is pretty much all the power. Well, I wouldn't say all the power it needs, but it's a really good starting point. I know a couple people have used brushless motors, but you need to make sure to get a sensored brushless motor. The sensorless ones, they have too much cogging, which is where the motor can't actually start turning. It's not as bad with RC cars because the chassis kind of gets rolling, but with this, I tried it and you literally can't start moving. So make sure to get censored brushless. We'll need some thread lock to start putting the motor in. In the kit, it comes with a separate little bag of the metric screws that I think pretty much all 540 motors use. And there is physically enough space here to fit the longer can 550 motors. You might have to solder the wires on vertically back here, but there is enough space if you want that motor. So I'll put some thread lock in here. And there's two 440 washers that fit these screws with no problem. And you want to mount the motor before you try putting the pinion on, because otherwise it won't fit. And just tighten these very loosely for now, just so we get the motor in here. So then the kits come with a total of 6 pinions. 2 of them are spares, but it comes with 3 different sizes. There's a 10, or actually I think it's 8, 10, and 12 tooth pinions. I recommend using the medium-sized one with this standard motor. If you use a really fast RPM motor, use the smallest pinion. And if you use like a rock crawler motor, I use the largest one. But they have it's like a clamp on instead of using a set screw. So what you do is basically start the screw on each side. And then there's a nut trap on the other side. Sometimes it doesn't work though, and you might need if you just hold pliers across. Like if you have the nut spin, just hold the pliers like that while you're screwing the other side. Because I know not everyone's printer is the same. Once you have the nut started, then you want to put it on the shaft. And it does take quite a lot of force to get this thing on. And then you'll want just a very small gap in between there. You'll see the pinion's actually shaped to avoid hitting the screws because the space is really tight in here. And then we'll go and tighten them up. Now these don't have to be very tight at all because it clamps down. So even a little bit of pressure is extremely good clamping. And you'll notice that the mount is pretty flexible. A lot of people are worried about that. But when you have belt tension on it, the belt tension is going to be pulling it outwards. But in the next step, when we put the belt cover on, the screw mounts into here and keeps it tight. So once it's screwed together, the mount can't actually flex in that direction. So it's not as weak as it looks. Okay, then we'll take the belt. To set the belt tension correctly, you want it actually really loose. Like you kind of have to play around with it. But the reason you want it really loose is because when you screw this cover on, it actually straightens the motor out like backwards like that, and it will tighten itself up as you screw that cover on. You'll be able to tell once you put it all together, or once you actually get the thing running. When you run it on low RPMs, you'll hear if it's too tight. But I normally have it, I'd say maybe about this loose. If you look at it straight on, you want like a lot of play in it, because the teeth are so large. Even if it's too loose after you put the cover on, it's very difficult for the belt to actually skip teeth, just because of how large of a pitch it is. And then once it's where you think is good, tighten the screws down, but not too much because you don't want to ruin the plastic mount that's on here. So next we need to actually mount the gear on the servo. The way it comes, the hole is just one size. There's so many different kinds of teeth on servo gears, I didn't bother trying to make it match. So what you do is you just press fit it on, but sometimes there's an extra lip on the bottom that you gotta carve out of there. I'll take some Loctite. Here's the screw that came with this servo, and I used a 440 washer with it. And then I'll take the servo and like start it on there. Try to press fit it just to get it started. And then I'll take the screw. Most servos you have to be careful doing this. Use a lot of force on the screwdriver to try to avoid stripping the teeth out, or the threads out of the gear, or out of the servo, I mean. But the screw will actually press fit the gear on, at least with a metal servo, which I recommend not using anything, like any plastic servo, like will not be able to turn the chute once it is out blowing snow, because snow piles up around the chute and then it can freeze a little. So you want a really strong servo to overcome any like freezing of the chute. So these kits come with a 10 kg servo, which has a metal output. I don't think this whole press fit thing would work on plastic, but I don't think any plastic servos are 10 kg. So there's the servo ready to go. And then we will take the belt cover. Actually, we need to do one more thing. Take a clippers, or you can use a file or Dremel, but most servos have a little notch there because we need to mount it upside down. So we'll take this and just clip it off. And then you can use a file just to make it a little smoother. Doesn't actually hurt the servo at all. And then the servo goes upside down with the gear in that groove there. And you'll use the number 4 by 1/2 inch sheet metal screws. And leave all these screws loose. We'll tighten them after we screw the belt cover on the snowblower. Now we mount the belt cover to the actual snowblower. We take 4 5/8 inch long number 6 sheet metal screws. One of them goes in that hole there, and the others go here. Alright, once you have it screwed in, then we can adjust the gap right here. You want some gap in between the chute, but not. I just basically just right in the middle, and then tighten it down. And then the kit comes with a fancy servo cover. I can't guarantee you it'll fit all servos, but it'll fit most servos. It certainly fits the one that comes in the electronics kit, but it just basically press fits on, just like that. This will actually protect, if it fits your servo, it'll protect it from any water or snow, so you do not need a waterproof servo. Because the way it's designed, no water could ever get all the way up to where the electronics are kept in a servo. It even covers the lip of the top of the servo that's connected in there. And then you'll also want to check the belt tension. See, like for me, this feels a little tight. So what I'll do is just quickly unscrew the belt cover. So to loosen it, I'll just loosen the top screw. Just move it down just a little bit. And then tighten it back up. And to do a quick test of the tension, you really only need to put in this screw right here. Yeah, see, to me this feels a lot easier to turn than it did a second ago. You'll also be able to tell when you're running the snowblower, if you see the motor moving a lot, that means the belt is too tight because it's pulling itself, you know, into the mount really hard. But you can see right now it's not really moving at all. So I would say this belt tension's pretty good. So then we can close it all the way back up. It's a lot easier running the screws the second time than the first time. But in all of the snowblower orders that I've built and my own, as many times as I've opened and closed my belt cover, I've not had any of these screws strip on me. Just because of how large of a thread they have on them. And because, you know, you don't over tighten anything. Just enough. So that's how you build your snowblower kit. One more thing is, once you're out using it, if you notice it bogs down a lot, and it seems like it shouldn't be bogging down, like when you're doing nice fresh snow, you'll want to turn the snowblower off, hold your hand on the impeller in here, make sure it's turned off, and then you'll use the 7/16 wrench. I do quarter turns at a time. Tightening it will make the snowblower more powerful, but it'll make it more risky for breaking auger blades and stuff. It'll take you a while to find the right balance where you want. Just don't over tighten it because you will break stuff. And keep your hands totally clear of the blades while it's running, because this thing is much stronger than it looks, and I'm not responsible in any way of any harm caused to you guys. Just keep your hands away from it when it's running. I'm going to be making several more video series of how to wire up the electronics in your vehicle, and I'll also be doing a video series on how to install the front and rear mounts on the Kyosho Blizzard. But if you have a custom vehicle, you'll have to design your own mount somehow. Like that blank bracket you basically just need to have a servo basically tilt the snowblower back up and down, and that's all your mount really needs to do. Also needs to keep tension pushing that way on the snowblower, because when you're running it, the augers will have a tendency to try to climb up the snow. But with the Kyosho Blizzard mount that I have, it pushes it into the ground nicely. So let's see, I'll just show you a little display of snowblowers. I do offer a blue one, and I'm thinking of offering a fourth color also, but for now it's orange, red, and blue. Post any questions or comments you have, and let me know how this whole build went, because this is my very first build video series I've ever made. So sorry if it was a little boring at times, but yeah, let me know if you guys had any questions on how to do certain parts of the build. So thanks for watching.